Tesla has invested a lot in its Gigapresses and continues to do so. But do those massive machines give an edge over the competition, and how much edge? Tesla as a company is used to doing big things, which makes it not surprising that Gigapresses would be found in its factories. These are huge by all standards, most likely dwarfing your apartment. A Gigapress is a die casting machine among the most powerful ever built, with capacity of 61 kilonewton clamping forces. They weigh more than 400 tons and require more than 20 flatbed trucks to transport only one. They measure 20 meters by 7.5 meters by 6 meters. They are made by the Italian manufacturing group known as IDRA, and the company has enjoyed Tesla's patronage more than a few times, with what we heard to be current multiple orders yet to be fulfilled. Interestingly, even though the name Gigapress goes with Tesla's Gigafactory, the name was actually coined by IDRA. Tesla uses the Gigapress to make the chassis in its cars in single pieces. This means the automaker deals with at most 3 parts instead of more than 100 if it had followed the practice of bolting and welding stuff together like the auto industry has been doing since forever. A Gigapress works like just any other die casting machine, as they use a plunger to force hot molten metal into a mold that will be reused. The impressive difference is the scale at which a Gigapress does it. To keep a fair idea, take a plastic toy car for example. The cheaper ones are usually made with a single solid piece before the tires are tacked on. Now imagine the whole chassis of a car made in the same way, but this time made from metal. The chassis will be at most 3 pieces, comprising the front and rear sections joined by a battery pack structure. The making of a vehicle chassis with a Gigapress takes place in different stages. The preparation step involves spraying soybean oil into the mold, which is needed to make it easy to remove the finished chassis easily. This is important for the mold to be easily reusable. The metal is melted using a furnace external to the Gigapress. Tesla combines aluminum and silicone to make its chassis, which technically means it's an alloy. The alloy melts at around 850 degrees Celsius, after which the right amount is forced into the mold by the plunger. After cooling down to 400 degrees Celsius, the mold is opened and the chassis is moved by a robot into a pool of water for further cooling to 50 degrees Celsius. Lastly, the chassis will be checked for defects and rough edges trimmed, after which all the required holes will be drilled in by robots. Gigapresses require a lot of investments and space for installation, so Tesla must have seen the clear benefits before committing to them. The fact is, the Gigapress is a game changer in the auto industry. The most obvious advantage is speed because despite their great proportions, they work very fast. Per IDRA specs, the aluminum silicone alloy can go from molten metal to a chassis in less than 100 seconds. That's a blistering speed when you compare that to all the steps and labor involved in fabricating and then fastening more than 100 parts together. It simply means Tesla can make more cars than the rest. JP Morgan visited a Gigapress in action and came back impressed. They did some quick math using a cycle time of 4 to 5 minutes and estimated that a single factory with 10 Gigapresses running continuous shifts can produce 350,000 Model Y chassis in a year. And that is because the Model Y chassis require 2 Gigapresses. That figure goes up when the Gigapresses work closer to specification by the maker. The ones at the Fremont factory have actually been observed to complete the job in under 200 seconds, even though they are still being optimized. This means a new factory can easily make 100,000 units in its first year of production. Such huge numbers are basically unheard of in the automaking world. Remember, Tesla wants to make 750,000 vehicles this year, and 50% more next year. One of the not-so-secret weapons is the Gigapress. With Gigapresses firing away in Fremont, Austin, Shanghai, and Berlin, the target of more than 1 million vehicles doesn't look so unattainable. The next advantage of the Gigapresses is cost saving, something Musk is fanatic about. Despite the considerable initial investment, the cost of production per vehicle goes down as they eliminate lots of operational costs. For instance, a single Gigapress makes about 300 robots redundant as there is not much coupling or much lifting work to do, according to Musk himself. And that is saying something after the debacle of his push for a robot-powered production process for the Model 3. The Gigapresses actually cut down on space requirement by about 30%.
Manufacturing cost is much less. We see about a 30% reduction in the size of the body shop.
Which may be surprising given the large sizes of the machines themselves. But less space and less robots means a smaller maintenance budget. People will lose their jobs, but from an economic point of view, gigapresses make a lot of sense. Think about the logistics involved in making more than 100 parts in different locations, monitoring for quality and transporting them to the assembly plant. Tesla is able to avoid all that with its army of gigapresses. All told, the cost of making a chassis drops by about 40% when gigapresses are involved. Again, remember, Musk really wants to make a cheaper electric car. With all the cost reduction here and there, that $25,000 electric car may be looking more realistic. We are aware Tesla is setting up research and production facilities in China for the express purpose of finding out how to make a very affordable car. You can guess a Gigapress is going to be among the first things to be installed. The cars themselves benefit from the single-piece chassis. For one, they are not plagued by defects inherent with welding and bolting parts together, like weak joints or misaligned parts. They also weigh less despite being structurally superior. This translates to more range for the same battery capacity. This basically means Tesla has found a faster and cheaper way to make better cars, overtaking its predecessors. Tesla continues to race ahead of the competition as it has placed more Gigapress orders from IDRA. It will likely use a Gigapress for its upcoming Cybertruck and semi-truck, even though more power will be needed to cast the former's steel structure. Musk revealed it would require an 8,000-ton casting press to make the pickup truck's rear body cast.
We're actually going to be using even bigger casting machines for the rear body of Cybertruck, so we'll be using an 8,000-ton casting press.
Interestingly, IDRA itself announced that an order for an 8,000-ton casting machine has been placed.
We have been able to secure the first order for an 8,000-ton die casting machine.
Without revealing who the client is, but it kind of gave itself away by revealing the Gigapress will be used for making new energy vehicles by a leading global manufacturer, which points at Tesla. Apart from that, industry expert Sandy Munro, who famously criticized the number of parts in the Model 3, has been informed by sources that Tesla will be employing 11 gigapresses across its 4 plants, in what will be a massive scale-up. The Berlin plant will have at least one when it comes online this year. There is one each already at Fremont and Shanghai. Tesla really isn't the first automaker to employ castings, as Cadillac, BMW, and Audi have used them in their models, but none has attempted it at the mega casting level Tesla is doing. Just how the rest of the industry will try to catch up remains to be seen, but we know it is not an industry that jumps at the chance to change things, so Tesla may be able to hold on to its edge for a while. Even JP Morgan predicts that only new startups stand a chance of following Tesla's lead here, as they are nimble enough to adapt to changes. For now, the only other company employing a Gigapress is located in South Korea and doesn't even make cars. Glovatech uses it to make components for its 5G telecommunication equipment. Our comment section is open.